Hello learners, welcome to this course on Embedded System Design using PIC16F877 microcontroller. In this tutorial, I will be describing about on how to provide a user input from PC and we try to activate the corresponding LED array depending upon the input. So here in this application, what we are going to do is we are going to activate the LED array depending upon the user input from the computer. So the computer will be connected through a MAX232 driver and to the microcontroller. So this MAX232 driver is used for two things. One is it will double the voltage and also it can be used as a voltage inverter. So why this is done in the sense the PC works with different voltage ranges, microcontroller works with different voltage ranges. In case of a microcontroller, PIC16F877 MCU, it works with TTL logic. A logic 1 is represented by 5 volt, logic 0 is represented by 0 volt. Whereas in case of a computer, a logic 1 is represented by minus 12 volt and logic 0 is represented by plus 12 volt. So we need to have both the voltage doubling also should be there and also inversion of the voltage also is required. So that is why we make use of a MAX232 driver. So this MAX232 is a 16-pin IC. So where you can see there is a voltage doubler and a voltage inverter. So we can connect on one side, we can have TTL logics. On the other side, we can have RS232 outputs. So this RS232 outputs can be connected to your computer through DB9 connectors. So here I have shown the DB9 connectors in male as well as female. So these are the pin details of your DB9 connector. So in case of a male connector, the pin number 1 starts from left, it goes on to right, and pin number 6 starts from left on bottom and goes on to right. Same way on female connector, it will be just opposite. The pin number 1 starts from right side, it goes towards left, and pin number 6 on the bottom from left, it keeps on increasing on the left. So the important pins here are the transmission pin, receiver pin and the ground lines. So other signals are used for handshaking modes. DTR, CD, DSR, RTS, CTS, RI, everything is a handshake signals. So right now we will take about these three lines, TXD line, RXD line and a ground line. So transmitter line, receiver line, so the signal in transmitter line and receiver line will vary with respect to the ground signal. So we will connect something like this. So from T1 in, the microcontroller transmitter line will be connected and R1 out, the microcontroller receiver line will be connected and the output of your MAX232 T1 out will go to pin number 2 and R1 in will go to pin number 3 of your computer. So this microcontroller transmitter and receiver lines are multiplexed in the port C. So port C6, RC6 is multiplexed with the transmitter line, RC7 is multiplexed with RX line. So these two pins can be used from microcontroller to interface with the MAX232 and from MAX232 the T1 out and R1 in can be connected to RX and TX pin of your DB9 connector and this DB9 connector can be connected to the computer. So now what we are going to do in this application is we are going to connect an LED array, 8 LEDs connected to port D from RD0 to RD7 and I am going to provide an input from the computer. So a number between 0 to 255. I am going to provide a number, a 8-bit number. In decimal, it will be represented as 0 to 255. So I am going to give a number from computer and depending upon that number, the LED array is going to get lighted up. So for example, if I send 0, then all the LEDs will be in off state. If I send 255, then all the LEDs will be in on state. So depending upon what value I'm going to provide from computer, the LED is going to go accordingly. So here one important thing to remember is, in order to send a number, I'm going to use 3 characters from computer. So if I want to send 0, I will send it as 0, 0, 0. If I want to send 10, I will send it as 0, 1, 0. If I want to send 200, I will send it as 200. So we will be sending 3 characters from the computer, and upon receiving the 3 characters, I will try to put that value onto the LED array. So that is what we are going to do in this application. Now let us go and discuss about the circuit part. So in Proteus 8 Professional, I have already created the circuit. So here I have a PIC16F877 microcontroller. So the oscillator circuit, where I am going to use a 20 MHz crystal, it is connected to oscillator 1 and oscillator 2 pin of your PIC microcontroller. And there is a reset circuit which is connected to the MCLR pin. So by default, this pin will be at logic high. Whenever I close the switch, it will go to logic 0. Thereby the reset operation will be carried out. So this is the minimum circuit required for a PIC microcontroller to work. Then I have interfaced a LED array to port D, RD0 to RD7. I have connected it to the anodes of the LEDs. Cathodes I have connected it to ground. Then as I said, RC6 is your transmitter line for UART and RC7 is a receiver line for your UART. So these 2 lines are connected to your MAX232 IC. So this MAX232, it works for both doubling the voltage as well as for inverting the voltage. So I connect the RC6 line, which is the transmitter line, to T1 in, and RC7 RX line is connected to R1 out. The output from the MAX232 T1 out is connected to the receiver line of your computer. So which is nothing but a DB9 connector. Instead of a DB9 connector, here I have used a virtual terminal. Same way, R1 in is connected to the transmitter line. So here it should be opposite. So transmitter should go to receiver, receiver should go to transmitter. So instead of using a DB9 connector here, I have used a virtual terminal, which means the DB9 connector will get connected to the computer. So thereby whatever we see in the computer, that we try to visualize using the virtual terminal here. And the capacitor values of 1 microfarad is used for voltage doubling as well as inversion purpose. Now let us go and discuss the program which we have built using the MicroC Pro for PIC. So this is a MicroC Pro for PIC IDE. So here you can see I have selected the IC as PIC16F877 and the oscillator frequency is set to be 20 MHz. So I declare few arrays UART underscore RD, X underscore data as a character array which can hold 4 characters. A value variable is initialized to 0 and K is initialized to 0. Since we are using port C 6 and 7 transmitter and receiver lines, I configure the pins as to C equal to 0x80. So 80 represents 1, 0, 0, 0, 0, 0, 0, 0. So here this RC7 is configured as an input, RC6 is configured as an output, because RC6 is a transmitter line and RC7 is a receiver line. So it is configured as an input, RC7 is configured as an input, RC6 is configured as an output. Then since we have connected the LEDs to port D, I have configured all the port D lines as an output pin by specifying 0x00. So which means, so 0, 0, 0, 0, 0, 0, 0, 0. So all the port D lines are configured as output lines. Then I initialize the port D value to be 0x00. Then you initialize the UART communication with a baud rate of 9600. So 9600 bits per second is the data rate. So we wait for some time for the UART to get initialized. Then I'm going to check whether the UART is working by sending a text. start. Then we put a new line and a carriage return so that it will come to the next line. So now in the while loop, I want to check whether the data is coming from the computer. So once the data comes from the computer, I have to get the data. As I said earlier, from the computer, we will be sending three datas. If I want to send 200, I will send 200. If I want to send 10, then I will send 010. If I want to send 5, I will send 005. So three characters, we need to receive it from the computer. So in order to do that, I use a do while loop here. So this do while loop will run until I get three characters. So first do, I'm checking whether any data is received from the computer. If data is received, then UART1 underscore data underscore ready will be 1. So if that is the case, I am reading the data, put it onto UART underscore RD of K. So K I have initialized to 0, which means when the first data is received, I put the data onto UART underscore RD, in bracket I put 0. So 0th location I put the first character. Remember, when I input the data from the PC, it is a ASCII value. I want to have a hexadecimal value. So what we do here is we bitwise AND this UART underscore RD with 0x0f. So for example, if 1 is, for example, in ASCII chart, if you see, for 1, it will be 0x31. Hexadecimal value is 0x31, which is a ASCII value. So I want to have 1. So which means I am going to do 0, 0, 1, 1, 0, 0, 0, 1. So this is 3, this is 1. So this is the ASCII value for 1. So I want only 1. I don't want this 3 to be there. So in order to remove this 3, what I do is I do bitwise AND of 0x0f, which means I get only the lower part, lower nibble, whereas the upper nibble will be turned on to 0. So after doing this operation, I get the lower part alone. So 0000, 0001 will be available in the x underscore data of 0. Then I increment the k because I have received one data. So I will try to increment the k. So now the k value will become 1. So once the k value becomes 1, I am going to check the condition whether k is less than 3, because I am going to receive 3 characters, k equal to 0, k equal to 1 and k equal to 2. So I am going to check whether I have received the 3 characters. No, only 1 character is received. So again I go to the do loop. Again I am checking whether any data is available. If data is available, I am going to read it. Now the data will go to UART underscore RD of 1. Then same way, in order to change from ASCII value to a normal hexadecimal value, I do this operation and again I try to increment the value. So now the k value becomes 2. So then again I check whether k is less than 3. Yes, it is less than 3. So again I will go there. I will try to check whether any new data is received. If new data is received, again I read the data, put it onto UART underscore RD of 2. Then again convert the data to a normal hexadecimal value. Now the k value becomes 3. Once the k value becomes 3, this condition will not be satisfied. So it will come out of the loop. So once it comes out, I have the 3 datas which we sent it from the PC. So now I am going to check whether my k value is 3. If my k value is 3, I am going to initialize the k value to be 0. Now I want these 3 characters. For example, if I put 255, so in UART underscore RD of 0, I will have 2. Then UART underscore RD of 1, I will have 5. UART underscore RD of 2, I will have another 5. So 255 is that. So I want to convert it into a single value. So in order to do that, what I do, I take x underscore data of 0, multiply it by 100, which means 2 multiplied by 100 plus 5 multiplied by 10 plus 5 multiplied by 1, which means 200 plus 50 plus 5. So which is 255. So this 255 will be put on to value. Same way, if my input data is 100, or let us take it as 1, 2, 3, I have sent it from the computer. So then what happens? 1 into 100, which is 100. Then again 2 into 10, which is 20. Then 3 into 1, it will be 3. So 100, 20, 3. So 100 plus 20 plus 3, it will be 123. So 123 will be residing on value. Now I send this value to port D. In order to visualize the result, I retain it for some 1 second. Then I make the port D to be 0. So whatever we sent from the PC, it will get displayed on this LED array connected to port D. So now let us compile this program by building the program. Now let us go and put this hexadecimal value onto Proteus environment. So right click on the microcontroller, edit properties, select the file. So the file name is led_uart, which is a hexadecimal file. I try to import into that and then set the processor clock frequency to be 20 megahertz. Then press OK. So now let us visualize the output. So when I press the play button, so first the UART communication start is received. Now let me send a character. So first let me send 0, 0, 1. You can see here 0, 0, 1 is being displayed. Right? So RD7 to RD0. So you have to look from bottom to top. So it will be 0, 0, 0, 0, 0, 0, 0, 1. So let us send another value. I'm going to send it 10. 10 means I should get 0, 0, 0, 0, 1, 0, 1, 0. Right? So when I send 10, so in order to send 10, I have to put 0, 1, 0. Okay, so you can see 1, 0, 1, 0. So let me show it again. 0, 1, 0. You can see 1, 0, 1, 0 here. So if I want to make all the LEDs to glow, then what I have to send? I have to send 255. So 255 means all the LEDs will be glowing. So let me send 255. 255, you can see all the LEDs are glowing. If I send 127 of the value, then you can see 0, then 7 ones can be displayed. So whatever value we send from PC, so that value gets displayed using the LED arrays connected to port D. So here one important thing is, since our port D is a 8-bit port, we can send only a 8-bit value. So our value should vary from 0 to 255. It should not exceed 255 because only a 8-bit value can be sent. So 0 to 255, we can send it from our PC. So in this tutorial, I have described about on how to send the data from a PC and that data how to display it on a LED array. Thanks for watching. Please subscribe for more technical learning. Thank you.